Dear students, welcome to Sia's digital classes. Today's topic is arithmetic mean, or just we call it as mean. So always we want to know about the average, on an average, how the performance is. So to know that, we have first method is mean. So different averages we have actually. So in that, let us discuss first topic, that is our arithmetic mean, or simply we'll call it as mean. So mean is the most popular method for calculating averages. It's just an average, what we'll do in daily life or regularly, whatever the averages we calculate, that itself we'll call as mean or arithmetic mean in our statistics. So to calculate that mean, we have different methods again here. So methods we have based on the data. So whatever methods you will get, that also will be based on the data they have given data. So we have three different methods, that is the mean for individual data, discrete data and continuous data. So individual data is nothing but single data they'll be specifying, like ranks of the students or marks of the students. So single line data they'll be giving. So by seeing we can identify that is a individual data, or ungrouped data also we call that. So ungrouped data or individual data is nothing but specifying single row or a single column data. For that particular data, we'll be doing mean. So next is your discrete data. Discrete data is nothing but two different types of data they'll be giving, in the sense like ranks. Just now I said ranks, general ranks, if they specify without any further resemblance for that. So here what they will do is ranks they will give with respect to their roll numbers. So roll numbers they'll specify, then ranks they'll specify. So particular roll number will get particular marks. So two rows they'll be specifying. One is X, one is F we call. X is nothing but roll numbers, F is nothing but frequencies. Frequencies in the sense ranks. So frequencies, most repeated values we can call. So particular roll number has got particular rank. So two different data, two rows if they specify, that is your discrete data. Next is your continuous data. Continuous data same as discrete data, two rows they'll specify. So nothing but here data will be continuous, like just now I said for discrete data, roll numbers and marks they will specify, isn't it? So here roll numbers will specify first in terms of class intervals. Class intervals is nothing but lower limit, upper limit they'll specify. Lower limit, upper limit in the sense we'll call as class intervals. So like ranks from 10 to 20 or 0 to 10, 10 to 20, 20 to 30 has got marks 25, 35 like that. So previously for discrete data, directly roll number 1 has got 20 marks, roll number 2 has got 30 marks, like that we used to take for discrete data. Now for continuous data itself will be continuous, like class intervals we'll call them, like 0 to 10, 10 to 20 like that. So whenever data is ranging between two intervals, that is called continuous data. So data is continuous, right? Like 0 to 10. So roll number 1 to 10. So 1 to 10 students has got 25 marks. So I'll specify together 10 to 20 or 1 to 10, all has got 25. So why to specify 1, 2, 3, 4? So directly 10 to 20 will get a 25 marks, like that. Such a type of data we'll call continuous data, because data is in continuous frequencies. There continuous data, class intervals and frequencies both they'll specify. So these are the three different types of data which we'll deal for mean. So first method, let us discuss mean for individual data. So these are the steps which we'll be using for individual data. So mean is nothing but we all know that it's an average. So sum of the data divided by its total. So that's what we have here. The steps are: calculate the sum of variables given and denote it by summation x. So summation x we should remember. Summation is nothing but adding. Summation symbol is nothing but adding the data. So first we'll sum the given values. Like I said, no roll numbers. So all the roll numbers you have to add up. That is your step 1. Next step 2, divide summation x by number of observations. That is capital N. So we have to divide by its number of observations. Like 10 ranks I have taken. So 10 you have to divide by 10 to the sum of observations, means whatever the ranks you have added, for that you have to divide by 10. So that is your actual arithmetic mean formula. So generally what we'll take for mean, what you will take for average is the same thing. Sum of observations divided by number of observations. So symbolically means in statistics, notations we'll consider. In notations denoted as x bar. X bar is a notation for mean, and its formula is summation x by n. So summation x, total of the observations divided by its overall total. How many are there? Count it and divide it. That is your capital N. Let us check it out, that particular data, in the form of some example. So example they have given here. Check it out the data. It is about some calculate arithmetic mean of the monthly incomes of the families in certain locality in Hyderabad. So in Hyderabad, some data they have given about some monthly incomes of some families. So check it out the data how it is. First row is family, the second one is income. So families, particular families has got particular incomes they have given. So only incomes you have, that becomes our individual data. That is the clue that it is an individual data for us, because nothing else information we have, only some income of some particular families. Those are in variables. That is also one more clue, is that the families has been specified in particular variables A, B, C, D. So A, B, C, D we can never calculate, or we cannot multiply with or we cannot add them. So that's a clue that it's an individual data or ungrouped data. So let us go for individual data formula for this particular example. So what we have to do is, for this particular example, we need to calculate some arithmetic mean. So arithmetic mean, just now we discussed the steps how to follow. Let us do that with the help of this example. So make into columns. Every time they'll give in rows, so make it into columns. Family first column and income second column. The income, whatever you have, whatever the titles they'll give, that particular data goes as x. Consider it as column x. Means we have formula summation x by n, right? So the column, take it as title as x, income column, and write down all the values whatever you have given data as it is. You copy into the column, then add up each and every value. 180 plus 150 plus 120 plus 200 plus 250 plus 100 plus 160 plus 240 plus 1000 plus 800. So add it and you will get summation x. Summation is nothing but adding. So summation x, overall total you will get as 3200. So that's how you will take the x column. Entire data you have to add up. So you got some total. Now go for the formula. X bar is equal to summation x by n is your formula. Summation x, just now we have done. Capital N, I said it's an count the data. So we'll call as number of items or number of observations in the data. So just to count it, how many are there, how many families are there, A, B, C, D, like that. You go on counting up to Z. We got 10 samples over there. So counting is your capital N, counting the given data. So 10 families are there. Capital N becomes 10 for us. So take that 10, divide with the summation x, so that is your 3200 divided by 10, you'll get as 320. So that's what is your calculating of arithmetic mean for individual data. The individual data we have learned already that in our single data we have, that is your individual data. So that is individual we have done. Now let us go for mean for discrete data. Discrete data, as I've explained earlier, discrete data is we have two different types of data over there, like two columns or two rows you'll be having. Like just now we have taken family example, right? Only family and its income. Its income they have given, so single data, individual you have done. Now discrete data, two types of data they'll give. So let us see the example so that you can understand properly. So check it out the example here. Marks of the students they have given and the number of students. So X and F. So two rows we have. Some marks to the particular exam. They have done a particular exam. In that they got some marks, and how many students have got that marks they have given. So X and F. Such a type of data we call as discrete data. Now let us observe the methods, step how to do for discrete data. So these are the steps to find out the discrete data. The following are the steps followed for calculating arithmetic mean. Step 1, multiply the values of the variables x with the corresponding value of frequency. So I said x column will be there and frequency column will be there. So maintain a third column, and in that multiply both of them. X and F values you multiply. Take a title as fx and multiply them. Next, step 2, obtain sum of fx column and denote it as summation fx. So after obtaining the third column fx, multiplication column, just simply add all the values, you'll get its total. That is your summation fx will call. Next, step 3, divide the sum obtained in step 2 by total of frequency. So whatever the sum you got, summation fx, that should be divided by frequency total. So here one thing we need to understand that in individual data, capital N will take number of observations, will count the data and will give. In discrete data, check it out how the capital N goes on. So check it out the example, marks of the students and number of students they have given, right? So capital N, check it out, capital N is the total of frequencies, not the number of observations. So we need to do the total, like 4 plus 6 plus 8 plus 10 plus 12 plus 14. That is your capital N. That is your total of frequency. Frequency, right? F is nothing but frequency. If you add up that frequency, then you will get capital N. Individual data, you will get by counting the number of observations. For discrete data, add the frequencies, then you will get capital N. Now it's clear with the capital N. Let us go for fx column. Just now we have checked the steps that fx we need to do. That is frequency multiplied with x. So 4 into 10 you have to do. First value of frequency multiplied with first value of marks. So 4 into 10, 40. Similarly, go for the next value. 6, f value is 6. 6 into 20. X value is 20. 6 into 20, 120. Like that, calculate for each and every value. Like 8, next value is 8 you have in frequencies, and 30 you have in marks. So that 8 into 30 goes to 240. Similarly, calculate for each and every value of f into each and every value of x. 10 into 40, 12 into 50, 14 into 60, that all you go on doing, you'll get 400, 600, 800. So simply multiplying f column with x column is your fx column. Then add up all the data one by one. You add up 40 plus 120 plus 240 plus 400 plus 600 plus 840. You'll get its total as summation fx is a notation because we are adding up one to another. So summation fx is equal to 2240 we got. So simply adding entire last column. Now let us go for the formula of discrete data, mean for discrete data. X bar is equal to summation fx by n. So summation fx, just now we have done 2240, substitute over there, divided by capital N, you got as 54. That you divide here, 2240 divided by 54, you'll get x bar is equal to 41.48. So that's what is your final answer for discrete data, arithmetic mean for discrete data. So this is how you calculate for discrete data, arithmetic mean for discrete data.